Well, hello everyone, and welcome back. For today's What If, I will be doing a replacement. I will be replacing every planet in the solar system with the planet Earth. While that might not seem like much, it does have an effect over the solar system. So, one thing you need to keep in mind is that everything had to go right in order for us to be here. So before we get to that, let's just do a recap of the habitable zone. You can see basically you want to be in green, red, blue, anything past blue. You'll be in trouble if you're living on a planet that are in those zones. And I'm just zooming in just to first. I'm trying to see if it actually shows the sun's mini orbit. It does have a mini orbit, and I realized that in order to show it, because it's very small or very short, I will have to speed things up, and that's basically what I'm realizing in this particular action. And the reason for that is when it comes to orbits in the solar system or any astronomical orbit, two objects rotate around a particular point, and usually the point of the orbit, both objects are orbiting each other, but both of those orbits are in the object that is most massive. But in case of the sun and Jupiter, Jupiter is very massive. It's actually pulling on the sun just a little bit, and that point or barycenter that they're orbiting around is just outside of the sun, and you can see the sun's doing a little bit of an orbit. That is because of Jupiter. Now, I, I hope you're starting to see what the ramifications are of replacing every planet in the solar system with Earth, because Earth is not as massive as Jupiter. Therefore, this should be a very interesting what if to see what happens if we replace all the planets with the planet Earth. It just so happened that instead of the different planets forming as the solar system began, they were replaced with Earth. Okay, now I'm just baselining to what Universal Sandbox is showing in terms of life likelihood and Earth similarity. What I mean by that, or what this means, is how similar these things are to Earth in terms of Earth similarity and life likelihood. Earth is full of life, and we'll be replacing these planets with Earth as it is now. Not when it was first formed, in which there was no life, or not in the future when the sun begins to die and just wipes everything out. No, Earth as it is now, full of life. And I'm just baselining with Mercury, Venus, turning off the habitable zone because planets cannot have habitable zones. And then we're just seeing what the life on Venus is. I hope it's zero, because if it's not zero, then we're going to have some problems. But it's zero. Yes. Earth, 91% good. Everything is good. Mars, zero. I'm not really interested in Earth similarity, but it's there for your reference. Jupiter, going down, zero. Then we go to Saturn. Oh, it is a good time to look at Saturn if as of March 23rd, because the Earth is parallel to the ring, so it'll just be a flat line. Uranus is about 0.0238%. Neptune is about 0.0272% in terms of life likelihood. Okay, we're baseline. Now it is time to begin the process of replacing all the planets with Earth. And we'll see how it goes. All right. Let's take a trip to Mercury. All right, Mercury, you're about to become Earth. All right. All right, it's Earth now. Venus, about to become his twin. Is much healthier. Well, not healthy, but it's about to become Earth. All right, it's now Earth. Earth remains Earth. Mars becomes Earth. Now, if you look at the habitable zone, you might get a feeling of how all this is going to turn out. But let's still go through it, see what it looks like. Jupiter about to become Earth. Not as massive. That does have ramifications. It's not going to be shown in this particular simulation, but that does have ramifications. Saturn about to become Earth. And then Uranus. All right, time to become Earth. And then Neptune about to become Earth. All right, all the planets are now Earth. As of right now, all these Earths are full of life. But remember, a lot of things have to go right in order for us to be here. From position to how the planets form, all that had to go right. Now let's begin the process of putting things in motion, because right now everything is paused. Everything, Earth is as it is now, not taking into consideration where it is. And now everything is in motion, close to the sun, far to the sun. All that is starting to have an effect on all these different Earths. And let's just speed things up to accelerate this process. The first thing let's look at is the sun, because again, Jupiter has an effect on the sun. And as we zoom in, you can see that in the beginning of this video, the sun was doing loops. And now it's just going straight because the sun is also in orbit around the Milky Way. We are not stationary. The solar system is not stationary. It is moving. And that's because the sun is in orbit around the Milky Way. All right. So that's gone. So that the mini orbit is gone. Now let's see how all these Earths are responding to different placements in the solar system. Just zooming out. I'm really zooming out just to check, do an orbit check to see if there's any change to the orbit. I would think it would be, because now it's a larger well, it might make sense. There's no friction in space, so whatever speed they were going, it took over that orbit, so it should remain. But I would think that because of the mass, that would reduce the force of that particular object. But I'm not going to think much into that. As of now, according to the simulation, the orbits are still the same. Now, it probably would affect their moons and things like that, but the orbits are the same. But there's also another effect that all these different Earths, where they're placed, would have an effect, is because the habitable zone. So what we referenced way back in the beginning. Too close, too far, too hot, too cold. That impacted how life formed on the Earth. And therefore, let's begin the process of seeing how that is. So we're just going to zoom in, and we're just going to begin the process of seeing how it is. Okay. Earth is basically in Mercury's orbit. And you can see life likelihood is starting to go down. It's much hotter. It is not pleasant for all those people on Earth being that close to the sun. You can see the average temperature is 334 degrees C. That is not good. And that is pretty far from the sun. Mercury is not up close. It is a good deal away. Space is wide, and it's that hot. That is not good. Okay? All right. Next, let's check out Venus and where it Earth now being in Venus's orbit. All right. Life likelihood 2.0. That dropped from 91. It's going down. Now, its average temperature now is 142 degrees C. Venus is around 400, but that's because Venus has a runaway greenhouse effect. Bit farther from the sun, it's getting warmer. We go to we go to go to Earth around 7 degrees C, which is where we want to be. Earth, where Mars would be, life likelihood is 55. It's starting to go down. Its average temperature, and you can see it's pretty much frozen. That will be a common theme, but its average temperature is minus 78.1 degrees C. Yes, we're getting farther from the sun. It's getting very cold. We go to where it was, or where Jupiter was, minus 176 degrees C. Common theme, getting cold, life likelihood 9.82%. Life is going down. It's freezing, which is to be expected. We go to where Saturn once was. Yes, the common theme, life likelihood 7%, minus 199 degrees C. Farther we get from the sun, the colder it gets. All things being equal. That's why it's really great for this what if, because everything is equal and you're starting to see where the positions are. Uranus about negative 210 degrees C. Yes. Life likelihood 5.81. Further we get back, things are rapidly decreasing. And then we go to Neptune, negative 213 degrees C. And you're zooming in and out. I think the life likelihood was around, I think, 5%. And then we'll just zoom everything up. This is really just a check to see if their orbits change. Their orbits are not changing. Although, as you saw earlier, the lack of Jupiter has an effect on the sun. And to be completely honest, the lack of Jupiter would have an effect on the Earth. Now, you might be wondering, how did that happen? Well, Jupiter is a very massive planet. And because of that mass, it has a lot of gravity. That gravity impacts asteroids, impacts comets, impacts in terms of it tugs on them, it can manipulate their orbit. That helps protect us from asteroids. So that's why changing it with Jupiter can be very consequential. Now what I'm doing, I just returned everything back to normal. The planets are happy, everyone's happy, and I hope I will see you again. I hope you enjoyed this what if.